Alright guys, I'm going to do a quick review of what we talked about today. I'm going to put the PDF of these notes up since I know we took them on the whiteboard today. So I'm going to go through this pretty quickly. So the first thing we talked about, so 1.5 is all on factoring and different ways to factor. So the first way we talked about how to factor was using GCF, which we all knew was greatest common factor. So the steps for factoring using greatest common factor is to 1, find the GCF of everything, and that could include variables if needed, and then you're going to divide every term by the GCF, and then your answer becomes the GCF on the outside of the parentheses, and then whatever you got left after division is left inside. Okay. So we did an example, and you may have to pause this as you guys go through, just so you know, because I am going to do this quickly. So we did 2 examples. So the first example we looked at was 6x cubed y plus 45x squared y squared plus 21xy. So if you look at 6, 45, and 21, they all have a 3 in common. And that's the biggest GCF. And then you want to pull out the biggest x that you can without going over. So this pile has 3, this pile has 2, this pile has 1, so the GCF there is 1. This pile, I'm sorry, this was y cubed, and I didn't put the cubed on that y. 3 y's, 2 y's, and then 1 y, you only want to pull 1 y out. So we're dividing everything by 3xy. And then whatever's left is going to go in the parentheses. So 6 divided by 3 is 2. When you do the x's, you're subtracting their powers. So 3 minus 1 is 2 squared, or 2 x's left. And then the same thing with the y's. 45 divided by 3 is 15. 2 minus 1 leaves me with 1x. 2 minus 1 leaves me with 1y. And then 21 divided by 3 is 7. The x's cancel, the y's cancel. And that is your answer. And that is factoring using greatest common factor. Excuse me. So the next method is what I call goal numbers. You guys have probably never heard it called that, but it's x squared plus bx plus c. So it's when you don't have something in front of your x squared. So I call it goal numbers because the goal is to find 2 numbers that multiply to the last term but add to the middle term. So, and then it's going to factor into x plus or minus, like depending on what goes there, and then whatever your 2 numbers are going to go here and here. Okay, and that's not always a plus or a minus. Like, it's either going to be a plus or it's going to be a minus. So our first example is x squared plus 2x minus 15. So if I want to factor that, I know it's going to end up factoring into x and x. I want 2 things that multiply to the last term, so negative 15, but add to the middle term, which is 2. So factors of 15, you only really have 1 set, or you have 2 sets. You could do 1 and 15, but because it's negative, it's either going to be negative 1 and positive 15, or 1 and negative 15. And so it's not either one of those, because that's going to give you 14 or negative 14. So it's not those 2. So then it could be negative 3 and 5. If I do negative 3 and positive 5, that does give me 2. So I know that's going to be the pair, but if it wasn't, you would just switch it, and that's how you would get the other set. So I know it's going to be x minus 3 and x plus 5, and that's the answer. So that's factoring with goal numbers. So then we went through box and the grouping, you guys called it the AC method, or maybe that's not what it was, I don't know. So for the box method, you need to build a box. So let's say I want to factor 5x squared plus 7x minus 6. So step 1 is to build a box. You put the 5x squared in the first box and the negative 6 in the last box, and you multiply them. So I want two things that multiply to negative 30x squared, but add to the middle term, which is 7x. So 30 has a couple different factors. You could do 2 and 15. Again, we're multiplying to a negative, so it's going to be negative 2 and 15, which is going to be 13. If you reverse that, you're going to get negative 13, so I'm not going to reverse it. We could do negative 3 and positive 10, and that does indeed give me positive 7. If it didn't, you got negative 7, then you would just switch it. Because I need to multiply to x squared, but add to x, these both have to have x's on them, because x times x is x squared, but x plus x is just plain x. So those are going to go into your last boxes, and the order in which you put them in there does not make a difference. You can switch them around. So now you're going to go through each row and column and pull a GCF out. So 5x squared and 3x have an x in common. 10x and 6 have a 2. 5x squared and 10x have a 5x. And 3 and 6 have a 3. Because this is negative, we're going to put a negative here. And because this is positive, we're going to put a plus sign there. So your two factors become x plus 2, 5x minus 3. Excuse me. So that's the box method. Using the same example, we're going to do the AC method, or grouping. So you're going to multiply a times c, which is negative 30x squared. So I want to find two things that multiply to that, but add to 7x. So as we found before, it's going to be negative 3 and 10, because it's the same example I just did. So what we're going to do is we're going to take these, and we're going to replace that middle term with them. So this becomes 5x squared plus 10x minus 3x minus 6. So then what we're going to do is we are going to group the first two terms and group the last two terms. Find the GCF of each of those. So the GCF of 5x squared and 10x is 5x. So when I divide both of these terms by 5x, I get an x plus 2 left inside. And over here on the 3 and the 6, I can pull a 3 out, negative 3. So then I'm left with x plus 2 inside. So then whatever's on the outside should be one factor, and the inside pieces should always match if you're doing this correctly. So then you get x plus 2. And that is the AC/grouping method. So then we talked about doing perfect square trinomials. So PST stands for perfect square trinomial. And the rule for a perfect square trinomial is if you have an a squared plus a 2ab plus b squared. So if my first term is a perfect square, my last term is a perfect square, then this will factor into a plus b squared. If it's a squared minus 2ab plus b squared, so if this is negative, then this is a minus b squared. Okay, so an example of when you would want to use this is 25x squared minus 20x plus 4. So I know that 25x squared, the square root of that is 5x. I know that square root of 4 is 2. And my middle term should end up being 2 times the first term times the last term, which it ends up being 20x. So that works out. So then we said this factors into 5x, 2, and then I'm going to square it. But since this is a negative here, and this is 5x minus 2 squared. So then the last method we talked about was difference of squares. And this is if you have a squared minus b squared. This only works if it's a squared minus b squared. If it's a squared plus b squared, does not work. So if it's a squared minus b squared, then that factors into a plus b a minus b. So an example of this would be 9x squared minus 25. Square root of 9x squared is 3x. Square root of 25 is 5. So this factors into 3x plus 5, 3x minus 5. So then along those lines you have the sum or the difference of cubes. So this is if you have a cubed plus b cubed or a cubed minus b cubed. And the rule for this is a plus b, and then a squared minus minus ab plus b squared. And if it's minus in the middle, then this is a minus b, and then these are all pluses. So an example of this would be x cubed plus 512. Well, x cubed, the cubed root of that is x. 512, the cubed root of that I think is 8. I think is what we decided in class today. So this becomes x plus 8. I'm literally just plugging it into this equation. X squared minus 8x plus 64. And that is it. Okay, the last example, and probably the most complicated example that we have, was factoring with negative exponents. So the example of this I gave you was 3x, x plus 2 to the negative 1/3 power, plus 4 times x plus 2 to the 2/3 power. What the fudge happened? So my rule for you was to find factor out the term with lowest exponent. And this has to be a term that's in common, obviously. So in our example, these two are the terms that are in common. This one has the lower term because it's a negative 1/3 power. So that means I'm going to pull out the x plus 2 to the negative 1/3 power. Well, what that happens is this whole term gets divided by x plus 2 to the negative 1/3 power, and so does this one. So these cancel, and I'm left with 3x. That part was easy. Over here, since they have the same base, that x plus 2 part's the same base, you leave that base alone and you subtract the exponents. So I have 2/3 minus a negative 1/3. Well, a negative makes a positive, and you get 3/3, which is 1. So this is going to become x plus 2 to the 1 power. Well, you can't leave your answer like that, so we simplified it to get 3x plus 4x plus 8. This gives me 7x plus 8. And then don't forget you have that x plus 2 to the negative 1/3 power out front. And that's it. So we did 1 through 49, and then 49 and 4 through 9 you needed to make sure you factored.